Srikanth and everybody else has talked a lot about Wi-Fi 6 and Wi-Fi 6E and where it is going and opening up of the 6 gigahertz band. People sort of are expecting a lot. What I wanted to do today is to look at what are the practical considerations of deploying a Wi-Fi 6E network. I really want to sort of look at beyond Wi-Fi as an enterprise. When you are thinking about deploying Wi-Fi 6E, what would you need to do? And it is, obviously this has come in because it's not as simple as you get up there, take off your old AP and then put in the new AP. That's probably not going to work when you go to Wi-Fi 6E, and I will sort of go through some of those things. I know it's a little bit early for India because we haven't opened up the 6 gigahertz network yet, right? 6 gigahertz is not yet legal in India, but it will happen. As you saw in Srikanth's talk yesterday, India is committed to working towards opening up the 6 gigahertz band in some way or the other. So if this is not going to happen now, this will probably happen, maybe a year down the line, year and a half down the line. And by the time the vendors would have also sort of started shipping the Wi-Fi 6E access points, so it will be a time that's ripe. So given that a lot of us here are practitioners of Wi-Fi, I wanted to just throw some sort of things that we have experienced when we have tried to do this in the US and other geographies, where 6E is already sort of allowed, people are using it right now. So wanted to do that. So I have this slide as a brief history of Wi-Fi. I don't know if I want to spend too much time on this because you all know about this. One of the key things that, I'll repeat what Srikanth said yesterday is that with Wi-Fi 6, what happened was that people wanted to improve the spectral efficiency of Wi-Fi. Until now, it was always about link speed, link speed, link speed. If you see, there's always been like a 10x, 11x kind of growth in link speed with every generation. This is the first time that we didn't really have a growth in link speed, but the focus was more on the improvement of the spectral efficiency of the Wi-Fi, so that you can do more without bringing new tricks and other things to just show off on the access point box that, first I was doing 54 Mbps, now I'm doing like 600 Mbps or so many Gbps, etc. But at the end of the day, what is required in an enterprise is that you have so many people that come into the enterprise, so many people trying to connect, everybody is now carrying 3-4 devices, and you really want to make sure that everybody has a good Wi-Fi experience. But at the end of the day, that doesn't sell what the number on the box sells, right? So we will go back to that, just a little bit of history. As I said, we won't spend too much time on it. But here is what the 6 gigahertz really promises us, right? So if you look at what it actually promises is that they're saying we'll get multi-gigabit link speeds with this, which means that you can transfer a lot of more data than what you used to do earlier, right? It also promises low latency, right? Where you're saying that, AR, VR, you will not see any lag, you'll be able to sort of, make sure that all of your applications are responding in a very, very quick time, voice and video applications will be absolutely seamless, etc. So what has happened with is that, we all saw that 5 gigahertz is now very crowded, 2.4, there are so many problems. With 6 gigahertz, the whole industry is expecting that we will get all of these benefits that was sort of promised with AX, but was not possible because of the sort of the backlog that we are carrying about backward compatibility, right? So, we have data to prove that even if one 11AC client comes into a 11AX environment, it actually brings down the throughput of the cell by about 30 to 40%, right? That kind of impact you see now. With 6 gigahertz, there is a huge promise. People are waiting for it in the US and some other geographies in Europe. Some of the people have started deploying 6 gigahertz. And there are some things that we need to consider, that when you go from 6 to 6E or from 2.4 and 5 and you add 6 gigahertz to your network, what are the practical considerations that you need to think about? So the first thing that you need to think about is the device ecosystem. So Wi-Fi 6E has started appearing some of the high-end devices out there. So some of the latest Samsung phones already have a 6 gigahertz radio. Some of the Dell laptops are very high-end, have 6 gigahertz radio. Apple is still not there, but it started to show up. It really started with the sort of end of last year when some devices started coming up. And now slowly we are seeing that 6 gigahertz ecosystem is slowly increasing. And 6 gigahertz access points are also being started shipping. So we as Arista and our competitors have started shipping APs that are capable of running 6 gigahertz as well. But one of the key things that we need to remember is that 2.4 gigahertz is not going anywhere, right? Everybody is saying that, oh, now that we have, 5 gigahertz and 6 gigahertz, do we really want to continue with 2.4 gigahertz? That's not going anywhere. A lot of devices that are out there that we see are 2.4 gigahertz. They work very well. They are pretty nice. They still have life. Printers, handle scanners. You go to some of the warehouses, you will see they have 10 years, 12 years old handle devices. They're not going anywhere. They're going to be there. 2.4 gigahertz, you will have to continue to support 2.4 gigahertz for a long time. So that's one thing that we have realized as we start sort of going into the market, looking at the ecosystem, what's happening. And even if 6 gigahertz is out there and some of the high-end devices are coming up with 6 gigahertz, dual band devices that have been sold, at least if you say in the last 7-8 years, right, they still have a lot of useful life. For another 2 or 3 years, you will still see that a bulk of the devices are not going to be capable of 6 gigahertz. If you look at the adoption rate, that is going to be very slow right now. Even if the adoption picks up, and we saw the Wi-Fi Alliance a presentation this morning. If you look at the number of devices that are already shipped, there are so many that even if you ship hundreds of millions of devices in the next 2 years, that is still a huge part of the ecosystem that will continue to remain. At least for the next 2 or 3 years, those older devices are not going anywhere. So what does this mean for an access point? So when you look at an access point, what this means is that you need tri-band access points. If you want to deploy 6 gigahertz, you still have to deploy 2.4 gigahertz, 5 gigahertz, and 6 gigahertz. You cannot say, I will drop one of the radios. Now, when you say that you need a tri-band access point, obviously it will mean more power that you need to supply to these, because it has to drive 3 radios instead of 2, right? Obvious. And they will be more expensive because there is more hardware. It is going to be a little bit more complicated because you've got more number of antennas. You have to put in filters. You have to do a lot of other things to make sure that you can operate all these 3 bands from that AP. So it's going to be expensive. It is going to require more power. And band steering will become really important because now you have devices that are capable of 6. You want to make sure that those devices do go to 6. Otherwise, what's the point of putting a 6 gigahertz AP, right? If your APs are going to stick to 5 gigahertz, if your clients are going to stick to 5 gigahertz. So band steering becomes really, really important, and that is one place that we have seen we have to do this. So this is the chart from a company called 650 Group. Sorry, I did not acknowledge them in the slide, but this is a slide from this particular chart you see there. So they've been doing research on the number of units that have been shipped. If you see that vertical line, the black vertical line is where we are right now, right? If you see Wi-Fi 6 devices is a bulk that is being shipped, but if you now do an integration of all the curves that you see before, you will see that even Wi-Fi 6 is not anywhere near where that ecosystem is. So even though Wi-Fi 6 and 6E devices have started to ship, we are still seeing a lot of devices out there. Now, device ecosystem is one thing, right? You have to make sure that you support what you have today. But the other thing that you need to really worry about is your network infrastructure. Now, when you have 6E, there will be new requirements from your switches, right? First thing that you will need is, as I said, more power. And when you need more power, your PoE switches need to have the power budget to be able to feed all of these access points, right? A bulk of these access points are going to be 802.3bt requirement, right? All of you probably know it's a 60-watt spec, which promises to deliver up to 53 watts to the PD. So you will need, so basically you won't be able to live within a 25.5 watt budget that is provided to you by 802.3AT. Now these switches are expensive. They need a bigger power supply, which means that if you have a rack which had 3 switches that were dedicated to deploying access points, suddenly you'll require that, you might figure out that you need a larger circuit at the back end to bring in even more power to your rack. So you need to think about these requirements. This is very critical. If you are thinking about Wi-Fi 6E deployment, make sure that you think about your switches and think about the power that these switches will require. We have seen deployments where, switches had to be, a couple of more fans needed to be added to the switches because it heats up more because it is driving more power. Air conditioning requirements go up. So it's like there is a cascading effect of what happens. The other thing that happens is that the backhaul needs to be able to carry all of that data. You are bringing in the third radio. You have seen a lot of spectral improvements that are happened due to Wi-Fi 6 or 11AX. And 6E now, taking away the backlog of the burden of, supporting older protocols, you will see a lot more traffic come onto the network. And once you do that, you will need APs that have, 5 gigabit Ethernet, or in some cases even 10 gig Ethernet, right? Now we can debate about do you need 5 gig or 10 gig or not, or what is the real life throughput, etc. But what will happen is that vendors like us will throw in a larger phi just to make sure that, it's there. And then obviously if you don't have that infrastructure on your switches, it doesn't make sense. So you need to make sure that your switch infrastructure, you kind of think about it, because typically, given the speed at which Wi-Fi has been sort of growing over the years, a usable life of a Wi-Fi access point is smaller than a usable life of a switch. So if you deploy a switch, you don't think about replacing it for maybe 6, 7, 8 years. But APs usually gets redeployed in about 3 to 4 years, right? Which means that some of your switches might have a lifespan that you had not budgeted for, that you need to replace those switches. So these are some of the practical considerations that I'm sort of bringing out. Again, I'm not going to bring solutions here. This is more about our experiences when we go and deploy Wi-Fi 6E. So I'm just bringing out what challenges we have faced. Obviously, different people will have different ways to solve this problem. So we're going to just talk about what the practical considerations are. One of the other things that we realize is really, really key is actually the cables that have been laid out, right? We've seen that a lot of people, even though their cabling was fairly new, maybe 2, 3, 4 years max, because that is when they had replaced their switches, is Cat 5e. Now, if you want to drive 60 watt power from a switch over 100 meters, right, and to make sure that you don't heat up your plenum and stuff like that, you should have a Cat 6a cabling. And that will obviously mean that you have to rip open your ceiling and put new cables. And a lot of time what happens, like, I'll give you one practical example that happened, which is, pretty amazing. We put up a Wi-Fi 6E access point. It runs fine for some time, and then suddenly it drops to 100 Mbps. It loses power, it drops to like 1180 power, and we were like, what happened? So we kind of went and checked the cabling and everything. Everything is fine. We are checking the cabling from the patch panel right to the other end. Cabling and all that is okay. Everything is fine. We're like, is there something wrong with our hardware? Is it something wrong with the switch? Is there something wrong with the cabling? Is it the way it has been laid out? Is it more than 100 meters? We do all of that. And the root cause happened to be the patch cable that was used from the switch to the patch panel. That was a Cat 5e cable. While everything else was done, that small patch cable that they were using from the switch to the patch panel, that was an older cable. So things like this will happen. So you have to be aware of those kind of issues, because APs need more power, they will be transferring more data. The other consideration that becomes key is that with the 6 gigahertz being available now, people have to protect themselves from a wireless IPS perspective from the 6 gigahertz band as well. Which means that you need to scan the 6 gigahertz band as well for rogue APs, for ad hoc connections are not really required, but there will be misassociations that happen. Like you are sitting on your window in the corporate enterprise, you had gone to Starbucks in the morning, your laptop connects to a Starbucks and not to the corporate access point, and you don't even realize that. So those kind of threats continue to happen, right? And obviously 6 gigahertz is something that people will exploit to try and get into the networks from an IPS perspective. So newer sensors need to come in with this adoption of the 6 gigahertz out there, right? Hackers are not waiting for you to adopt 6 gigahertz. They will start using it as soon as it's available. The other thing that is key, what we have realized is that some legacy devices have issues with the newer drivers that are coming up from the vendors, and when they go into the APs, like you mentioned in the morning, Srikanth, that people deploy something and then somebody comes and says, oh, my client doesn't work. What does the network administrator do? okay, I kind of turned on this switch, let me turn it back off. So you're going to lose all the benefits that you are getting because you're not able to support the legacy devices. So you need to think about upgrading the legacy devices. You need to be able to make sure that you get the latest drivers, you put it in there. And the other thing is that, using transition mode, you think you are now WPA3, but it's still legacy devices are going to, connect with open. That will leave out some holes in your network. You need to be able to do that. And then there has been cases when older devices that don't support 11W or PMF, they have a challenge connecting to APs in transition mode. Because, in some, that in C-regards mode, as we saw yesterday, 11W is now mandatory, right? So these kind of things will keep coming up. You need to make sure that your devices are capable of handling these things when you start deploying the C-regards APs. So obviously, just to kind of look at what we talked about until now, you need to think about upgrading your network, right? You need to think about, are you up for an upgrade or can you wait? Because your switches are anyway going to kind of get upgraded next year. Do you want to do the Wi-Fi upgrade also next year, right? That's one thing that you need to do. You need to factor in the changing of the cabling, which is a much bigger job than changing APs or changing the switches in the network. You have to think about your legacy devices. There will be a legacy devices which has a lot of lifespan left in it, right? Like I bought a TV about 2 years back, right? This is like a latest Samsung TV. It still has a 2.4 gigahertz radio in that. It doesn't even support 5 gigahertz, right? So people are still selling older devices with older chipsets, right? And these still have a lot of life left. And then I have seen in some cases where there are devices that don't have a replacement. We have a set of customers in the US who use a specific POS, a point of sale device. And those point of sale devices are using 5 gigahertz and 2.4 Wi-Fi 4, but they don't even have a replacement model available in the market today with Wi-Fi 6, right? So they have to continue to use the older ecosystem, and even if you want to move them to 5, it may not be possible. Some of these old handheld scanners in some warehouses, right, they are just so old, but their replacement doesn't exist, or even if they want to replace it, they have to replace their back end, they have to replace the systems that are behind it. It becomes a whole nightmare to replace that. This is one specific example that we had at one of our customers, a very large bottling company, right, one of the soft drink bottling companies. They said that if we change these handheld scanners, and they were doing web, which is no longer allowed, by the way. So they could not deploy our APs because they needed web. Now, if we said you need to change your handhelds because they are so old, they said if I change my handhelds, I need to change the controller of the handheld, I have to change the systems behind it, I have to change my sort of accounting system that goes with all of that logistics. It's just like a $10 million project which I can't afford. I can't replace the handsets as they are. So those kind of considerations will come in. And then one thing that we have been toying with some of our customers is, do you want to do a phased replacement? If you don't want to change everything right now, or if you have switches that doesn't have enough POE budget to be able to feed enough power to all the APs that are out there, can you consider just replacing one of them right now? Let's say in this room there are 5 APs. You replace one with a Wi-Fi 6E AP right now, right? You start using the C-regards from that, because only a small number of units are right now C-regards, but as time goes by, as you replace your switches, as you can do the cabling changes, you then start replacing the devices with Wi-Fi 6. So that's another thing that we have been suggesting to some of our end customers to try and do all of that. And then, what are the challenges in Wi-Fi 6E adoption? Where do you see people sort of pushing back on us, saying we don't want to adopt 6E right now, right? One of the things obviously is regulatory constraints. So we have some customers who are multinational, right? We go and pitch 6E to them in the US. They come and tell us, look, so many other countries that I operate in, and because I have a policy to have the same sort of hardware everywhere, I can't deploy it right now because 6 gigahertz is not available in India. What do I do, right? Other thing that we talked about earlier in the morning was AFC rules are not yet finalized. If I want to replace my outdoor APs, I can't today because we have to wait for AFC to be firmed up, everything else to be done before I can start thinking about even replacing my outdoor APs with 6 gigahertz APs, right? And some people who have moved to Wi-Fi 6E maybe last year, a year before that, they're obviously challenging as to, why should I do it right now? Why can't I wait for Wi-Fi 7? When is Wi-Fi 7 going to come? So right now, when we're trying to push Wi-Fi 6 into the market, we are seeing a lot of pressure coming back to us saying, should I wait for Wi-Fi 7? If this is going to happen in 2024, a lot of marketing sort of comes up and people start saying, oh, they'll start rolling out in 24, they'll say, I'll wait for another 2 years, right? So that's a current challenge to Wi-Fi 6 adoption. Sorry, you had a question? I can take it right now. No? Sorry. Okay. And then there's also a lot of talk about 5G, 5G NR or private LTE-based networks, where people are saying, oh, this is going to come in, and when we go and pitch Wi-Fi 6E to some people, they say, what is the 5G? Can I actually replace it with 5G? Can I replace it with private LTE? In the US, even CBRS band is available. So a lot of people are actually pitching CBRS now. What we actually advise people is that there are specific applications where that makes sense. If you have a specific application where you can spend the additional money to have a overlay network, it does make sense for you to go for 5G or a private LTE network, but it's not a replacement for Wi-Fi. General purpose access is not going to move to private LTE or 5G very time soon. The other challenge, obviously, of deploying a 5G network or a LTE network is that you need to have a very different sort of EPC, which is very different from your enterprise network. Today, when you deploy access points, Wi-Fi access points, it just ties in very well with your IP network that you already deployed, right? But if you do a private LTE network, you have to have a full EPC to manage that traffic. So there are challenges, there are opportunities where you can use it. There is a use case, so we tend to tell people that think about your use case, think about what you are going to do when you're putting in so much more investment for 5G. If there is a specific use case, one of the places where they have a manufacturing line, and there is a automated vehicle that actually brings whatever is getting exhausted on each of the manufacturing lines. So there are maybe 200 parts that goes onto every manufacturing line. There's an automatic trolley that kind of goes to the warehouse, picks up whatever it needs, goes to each individual line, and it's a pretty fast-moving vehicle. And that needs connectivity 100% of that. They need reliable throughput. They need very low latency. Something like that definitely makes sense to go for a CBRS-based network. But general purpose access is going to continue to remain with Wi-Fi for at least I think till I retire. I think that's how it's going to be. So the next thing that my colleague here will come and tell you is about the planning, coverage planning between 5 GHz and 6 GHz, and what are the challenges we saw there.
Is coverage planning. Especially I want to look at, or I want to share rather, how 6 GHz compares to 5 GHz in terms of coverage. So we did some tests at Arista, and I just want to share those. They're sort of initial simple tests, and I want to share those findings with you. So just to set context, this is the motivation we had. Obviously, we want to do better coverage planning, and Srikanth talked a bit about it yesterday, and I'll keep referencing that for those of us who were here yesterday. But the more specific motivations were, we wanted to characterize propagation differences, one in free space and across different obstacle types. Again, especially how 6 GHz compares to 5 GHz. And lastly, the effect of, it's been talked about a lot this morning. Also, there was someone mentioned it, I think it was Sujata, but Srikanth also talked about this yesterday. The interesting behavior in 6 GHz because of the power spectrum density limitations on channel bandwidths. So this is what I'm going to talk about. So we look at the free space across obstacle types and then the different channel bandwidths. So here's the sort of a simple test we did for the free space. This is outside our office. We had an AP here in the watchman's booth. And we basically took measurements, enough measurements or multiple measurements, so spread out over time. And we took them at different points away from the AP. So it's your classic rate over range type thing, except we're looking only at RSSI, not looking at anything else. There's no traffic, okay? Just speaking RSSI. So it's 5, 10, 15, all the way to 100 feet. That's what we did. And so I don't want to show you the RSSI interest. Instead, I want to show you something more interesting. So this is and bear with me here. I know it's always weird to look at a histogram, but anyway, I'll walk you through this. So this is the histogram of the dB difference in path loss. So you take the 5 gigahertz path loss, you take the 6 gigahertz path loss, you compute the dB difference, and then you plot it, how many samples in what bins do they fall, right? So the x-axis is basically your, bins for the dB difference. So this is how many samples. So 2 samples had, the opposite effect. Obviously, we all understand the 6 gigahertz. We expect it to have more losses than 5 gigahertz, but 2 samples are outliers. But then we find, something like, again, 2 samples where the difference was between 2 and 4 dB, meaning 5 gigahertz was 2 to 4 dB stronger than 6 gigahertz, okay? And we find that the bulk of the, samples, granted it's not a very large sample space, but this is, like I said, our initial findings, and we just want to share them. The bulk of the samples are between, 6 to 10 dB, which means that for the most part, I think it's safe to say that 6 gigahertz is about 6 to 10 dB stronger. Sorry, the other way around. 5 gigahertz is about 6 to 10 dB stronger in free space. No one pointed that out, so I'm not sure if people are listening, but okay. So that's the histogram of path losses on free space. Next, we looked at different obstacle types. Again, very simple test in our office. This, by the way, is our office. So we have 2 drywalls. You can see the sort of wall between 2 rooms here. That's drywall 1. The wall between these 2 rooms is drywall 2. And the AP was placed on a table in this room. And then we did, measurements here. One side of the drywall 1, other side of drywall 2. Look at the losses there. Similarly for drywall 2. And then we did something for concrete, which is outside the room. And then we did something for glass, which is behind the door and in front of the door. Okay? So here are the results for that. And again, I'm not going to, go too much into detail, but the general trend is very clear. By the way, this is path loss. So what this means is that consistently you see that 6 gigahertz, which is the blue line or the blue bar, has higher path loss, meaning it propagates worse than 5 gigahertz. The interesting aspect is that, at least in the initial findings that we see here, the difference is less pronounced when it's just one drywall, but you go to sort of 2 drywalls or concrete, meaning as the obstacle gets thicker, the difference starts to matter a lot more. So you see like 7, 8, 9 dB differences for thicker obstacles. But for just one drywall, it's about a 3 dB difference. But again, even for glass, there's a significant difference. So these are, again, for path loss with obstacles. And last but not the least, this is an interesting aspect of the 6 gigahertz behavior, is that we've all talked about this, that 5 dBm per hertz. Sujata talked about it, Shrikant talked about it yesterday. So going back to deployment considerations, this is an important thing to keep in mind, that your EIRP is going to vary with channel width. So for 6 gigahertz, you get your bang for the buck when you configure wider channel bandwidths, right? If you look at the blue bars, this is what you want to do. Shrikant talked a lot about it yesterday. I don't have that much time, but there's an interesting aspect to it in terms of the noise figure, where noise figure also goes up with bandwidth. So your net EIRP sort of levels out in some sense. But that means that you're sort of, you want to stay in this area, in the 80 megahertz, 160 megahertz with 6 gigahertz. And for other reasons as well, it makes sense if you're deploying 6 gigahertz. You've got wide spectrum better to deploy wider channels. So to sum it up all, 5 gigahertz, no surprises there, propagates better in free space, but I mean, significantly better, at least in the initial results we have. For obstacles, 6 gigahertz losses are in general higher than 5 gigahertz. We find that the difference is more exaggerated for thicker obstacles. And then this, PSD-based behavior means that, you must keep channel width in mind when you're configuring. If you want coverage parity between 5 and 6, right? You're better off using 80 or 160 megahertz wide channels. So that's all I have. Jatin, back to you for.
Yeah. So finally, just wanted to introduce to you one of the APs that we have, the Wi-Fi 6E AP that is currently shipping. It's also installed here right now, so the guest Wi-Fi that you are seeing here is actually coming through this model of the AP. So this is what we did when we did our Wi-Fi 6E AP. What we did is, one of the key things that we did here is that while we have 3 radios, one for each of the band, 2.4, 5, and 6, what we did is, because we knew about this, we kind of predicted that people will start asking us about, why should I invest in a 6 gigahertz AP right now when I don't have 6 gigahertz open. So one of the key things that we did is, we actually created a dual mode operation here, where you could either run it in a 6E mode, where you are running all the 3 bands, or you could run it in a dual 5 gig mode. So the 6 gigahertz radio actually operates in the upper 5 gigahertz. The 5 gigahertz radio is limited to the lower 5 gigahertz band. So that way, we allow the customers to actually deploy this right now and then replace it later, or turn on 6 gigahertz through a sort of a software upgrade when it opens up in the region of operation. So right now, you can deploy it in a Wi-Fi 6 mode, and then you can run it into Wi-Fi 6E mode when it opens up. There were a lot of challenges in this, right? The filtering that needed to be done, the way the sort of, separation between the 5 gigahertz radio and 6 gigahertz radio had to be done. There were quite a few sort of challenges that we kind of, saw here. The other thing is that there is a mode of operation for this AP that runs in Wi-Fi, in 802.3 AT mode as well, where you could sort of, we kind of dumb down it a little bit so that even if you provided 80 power, it does function in a very reasonable manner. Gives you the kind of experience that you need. Obviously, it doesn't do everything else. And then, as I said, right, we kind of put in dual 10 gig ports in here, not because we believe that, there'll be enough traffic to occupy all of that. It's just a spec. Everybody has to run the spec game, right? How is my AP better than my competitor's AP? So we went ahead and put in 2 dual gig backhaul with a dual PoE. So both of the Ethernet ports you can use to power the AP. So that way we sort of made sure that this is something that you can invest in right now and probably sort of, turn on 6 gigahertz later on. When you have it here, when you upgrade the switches, then you can turn it on into 802.3 BT mode. Rest of the things in this AP are that you find everywhere else. But this was something that we did. And as I said, you are currently getting Wi-Fi through one of these APs right now. So that's all. Any questions? I'm happy to take any questions.
So I was reading about this dual band simultaneous, right?
Yeah.
Where you can connect to both 2.4 gig and 5 gig at the same time.
Yeah.
Given that is coming and becoming popular, what do you see happen to 6 gig?
So that is a Wi-Fi 7 feature. So that's a completely different protocol. You will see a different class of, or a different generation of APs that will come up to be able to do that. Now, it is not just the physical radios that it is required, it is also the protocol stack needs to be able to support it. So as Srikanth was explaining yesterday, right, there'll be 2 Macs for 2 radios, but you will have a higher level which will have a sort of a multi-link MAC address. All of that stack is not a part of this, the software in the Wi-Fi 6E AP. So this is still 802.11ax. Only when we get 11BE in place, that's when all of that will be rectified. That is when it will come into the drivers and everything else. So this is not going to support that right now, right? Yeah.
The cabling for this is still...
So the cabling, so if you want to run it with full power, then you need to put a Cat 6A. You have to give it BT power.
For this mode, it will still work, the upper 5G.
Yes.
Okay.
Yeah, that will still work with the lower power.
Thank you.
The dual Ethernet, are you using it for load balancing or anything
Yeah,
like that?
so this is being used for redundancy, not for aggregating the power. Because aggregating the power, what happens is that like one of the port fails and you have to sort of start dumping it down. It affects the client connectivity as well. So we decided to kind of give this as a redundant option. So if there are two switches that you're connected to, two different switches. If I'm rebooting a switch, or if I'm doing some maintenance on that switch, it doesn't affect the operation of an access point because then it continues to operate it by drawing power from the other Ethernet port.
Yeah, hi Jatin,
Yeah.
nice presentation. I know your focus is on the enterprise, but
Yeah.
what are your views on the adoption in the home segment, which is more price sensitive?
So home segment will get adoption faster. This has been the case in Wi-Fi throughout its history, right? This is one technology, one access technology, where home use or personal use has always been in the forefront than as compared to the enterprise use case, right? If you look at Wi-Fi, the way it sort of picked up, and I'm talking about like maybe early 2000s, when we were not even doing Wi-Fi and people used to come and say, look, I'm using this cool thing at my home, like 11B kind of era. Why can't I use it in the office? Right? That was the one that originally drove adoption of Wi-Fi into the enterprise. So this has been the case. Wi-Fi home APs, Wi-Fi 6E home APs are available today. There are quite a few of them in the market. Obviously, you can't get them in India because SysGuard is not opened up. But those APs are available today. A lot of phones, handhelds on the higher end, except for Apple, almost all vendors either have a Wi-Fi 6E access point in the market or are actually building Wi-Fi 6E APs. You look at any laptop manufacturer, again, apart from Apple, they have something or the other, one of the models that do support Wi-Fi 6E, right? So it's like well into the ecosystem now. Home use has already begun. Enterprises are adopting right now. See, on the home, what really happens is that you are connecting this AP using a power socket with a AC to DC converter. Maybe you have repeaters in your home. You're not worried about Ethernet cabling so much. It's a much easier shift. You just take your one access point and replace it with the other, right? So home, it's already begun. It's already out there.
But the mass adoption, like the price points.
Yeah, so basically these APs, as I said, are much more expensive. Okay, let me not take that word back. Not much, but they are significantly more expensive than Wi-Fi 6 APs. Primary reason, you need one more radio in that. Because nobody is currently ditching 2.4, right? Because you just can't do it. Like I was saying, I bought a brand new TV about 2 years back. That only has a 2.4 gigahertz radio. I can't take away the 2.4 gigahertz access in my home today, right? So these are more expensive. And only the top-end handhelds and laptops today have Wi-Fi 6E radios in them. So these are more expensive. But I would guess by the end of this year you will see a lot more adoption of Wi-Fi 6E, at least on the handheld and the laptop and those kind of devices side, right? And obviously that will also spur the sale of home APs. So yes, it is expensive right now. It is cheaper today to deploy a Wi-Fi 6 AP than a Wi-Fi 6E AP, even at home. That's definitely true. But I think over a period of time, so if you see the rate of
So Jatin, in the interest of time, can we maybe take that
Sure.
offline?
Yeah.
If it's okay? Yeah.
Yeah.
So sorry, since we are just about time for this, so I'll thank Jatin
Okay,
and
thank
Preyas and thank Arista as Summit Partner sponsor.